Hello.
Hey Ramon, how's it going?
I'm good. Thank you. How are you, Laura?
Doing well, thanks.
Glad to hear it. And hey, everybody watching, thank you so much for joining. Um, oh, sorry. I'm hearing myself twice. There we go. Okay, cool. I hope nobody got a feedback loop, right? No, I think we're
I
fine.
didn't.
Fantastic. Yeah. Well, yeah, thank you all so much for joining. If you're joining in for the first time, hi, I'm Ramon. This is Laura, and we are so excited to be doing now a third part of our series of streams where we're doing Conway's Game of Life using Rust and WebAssembly. How's it been going for you so far, Laura?
It's been great. I mean, I've been learning a lot. Not like I could actually, code in Rust now, but I'm better at reading in Rust at least now. And yeah, this has been super fun and chill.
I'm glad to hear that. Yeah, no, same here. Like I'm pretty new to Rust myself, still learning a lot, but I think we're using this tutorial which is open source, and I will put up a link right now before I forget. I'll put that into the chat. There we go. If you all want to follow along, we are currently implementing our game of life in Rust, which will then get compiled to WebAssembly, and then we'll be able to use that from our front end in JavaScript, which I hope we'll be able to do. No, I'm pretty confident we're going to get to do that today.
Cool.
Awesome. Yeah. So, Laura, you'll be doing the kindness of navigating today.
Mhm.
I'll be driving. I'll be doing the writing, and folks in the chat, if you want to join in, make any suggestions, ask any questions. Like we're all learning here, so please feel free to chime in.
Yeah. All right. So let's see. So for the sake of context here, so we're on step. What is this step of the tutorial?
I
What's
think
the
this is
number?
step 3. Yeah, we're on step
Step
3.
4, right?
Oh, pardon me.
Well,
Yes.
4. I don't know. Anyway, yeah. So last time we created our function to count our live neighbors, and that's super important because that count is what's going to determine which one of our 4 rules we're going to be applying. It's 4, right?
Yes, I
Yeah, which
believe
of our 4 rules we're
so.
going to land in.
3 rules.
3 rules.
Oh,
3
no. No, no,
rules
no,
we're going
no.
to land in.
No, sorry. That was the 3 types of universe. Please ignore me.
Right. Yeah. Okay. Anyway, some number of rules. And we're going to have a refresher for ourselves, apparently, on how many rules there are, because we're going to implement them now.
Awesome.
So,
Yeah.
yeah, so we're going to start off with making our function that will implement our universe. And so, as we talked about last time, each generation, so each time we take sort of a snapshot of this is which cells are alive and which ones are dead, and then we apply our rules to each of those cells, and then we get another snapshot of the next generation. So what happens to each of those cells after we have implemented all of our rules. So here we go. So we're going to create this this universe, and we're going to have it's going to have a function called tick. And tick and generation, we remember, are synonyms basically in this context. So each tick, and the way Ramon explained this to me, like where the word tick would come from in this context, it's like a tick of a clock. So it's like a 1 second snapshot. Say, whereas second is, who knows what kind of units make sense in this context. But anyway, yeah. So we're going to create this MUT, and I also asked Ramon about this when we were previewing this. Why is it MUT? And the answer was that stands for mutable. And so mutable means something that can change, and immutable is something that is not allowed to change. And it's really important that this particular variable be mutable, because this is the one that's going to increment as we go through our live neighbor count for each one of these cells. So we definitely wouldn't want it to be fixed, but it is going to start at 0, I believe. Yeah.
Yeah, we're going to copy all of the cells in our universe. So this is like the next generation.
Yep.
Yeah.
Okay, yeah. And so we're going to loop through each one of these cells. So we're creating our for loop. So we're going to start with each row. We'll go through each row by column for the index for each one of our cells. Although, in fact, I mean, we're calling this row and column, but all of this data is stored in an array, right? And so we're just sort of waving our hands and pretending that what we have here is a matrix, because that's actually what would make more sense in our heads, and like that's what we're going to end up looking at is a matrix or a grid. But in fact, in reality, all of these are stored in an array, and so the columns are all each group of 4. So indices 0, 1, 2, and 3. That's a row, and then we have another row of 4, 5, 6, and 7, and then each of those cells inside those rows will be in a different column.
That's right. So, all right.
So we're going to determine which ones are alive and which ones are dead.
Yep.
Here we go. Yep. Count up our neighbors.
Row and column. Fantastic.
Mm-hmm. We'll get our next cell. And so why are we matching? Where did we define?
Yeah, matching is something that's built into Rust that allows us to, we're going to say, hey, set the value of this variable here, next cell, to be whatever comes out of this pattern matching scheme.
Okay.
Right? So in the case that, for example, our current cell is alive, and X is the number of neighbors, right? We're taking this and putting it, if this matches this pattern, right? Saying, hey, if the cell is alive and we've got a certain amount of neighbors, if that number of neighbors is less than 2, then that next generation will be, then the cell's next state will be dead.
Right. And so that's under rule 1, I believe it was.
Yeah, we can see it here. Sorry, let me see if I can scroll to the right a little. Maybe? Yeah. So if any live cell with fewer than 2 live neighbors dies, any live cell with fewer than 2 neighbors dies as if caused by underpopulation. And we can see setting that next cell to be this value if this pattern is matched.
Right. Okay, that makes sense.
Cool. So I'm going to go ahead and read out rule 2, if I may. Oh no, sorry, Laura. That's you're navigating not me.
Right. So rule 2 says that any live cell with 2 or 3 live neighbors lives on to the next generation. So if you have exactly 2 or exactly 3 live neighbors, then you get to live on to the next generation, the next tick.
Yeah. And we can see that expressed here. We're saying if it matches a pattern either of the cell being alive and the number of neighbors being 2, and we'll use the pipe operator to denote an or. So if it's alive and it has 2 live neighbors, or if it's alive and it has 3 neighbors, then the next state returned will be cell alive.
Yep. And then we have our next rule. There were 4. I love it when my memory is like correct. So then we have rule number 3, which says that any live cell with more than 3 live neighbors dies as if by overpopulation. So we'll have another line here. So if the cell is alive and the number of live neighbors is greater than 3, strictly greater than 3, then on our next tick, this cell will be dead. And we have one more rule to implement, that if it's rule number 4, any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. So in this case, right, if our cell is dead and our number of live neighbors is 3, then we're going to have an alive cell next time.
Fantastic.
It's interesting to me that in Rust, we don't say if then, we say if arrow. Like if and then implies.
Yeah, it's what's going on here. I mean, there are if statements in Rust. You can have like regular if condition and then expression, right?
Mhm.
However, if you've got a chain of them, having something like this, this pattern matching, because if statements in a way are kind of like pattern matching,
Sure.
or it can be used that way.
Yeah.
And here we're matching these specific patterns to then assign this value to this variable.
Mm-hmm.
But of course, like in the fifth case we have here, what about every other case? Right? Because here we're matching this pattern.
Mm-hmm.
We're matching this
So what
pattern.
if we have, so we've covered the cases where we have fewer than 2 neighbors.
Yep.
Okay, so we've covered 0 and 1 live neighbors. We've covered exactly 2 or exactly 3 live neighbors. We've covered what if we have more than 3 live neighbors.
Mm-hmm.
Wait, those are the only cases.
Right.
Or if we're dead and all of the rest of them are dead. All the rest of the uncovered cases are dead cases, right?
For
because
example,
what if we're dead and we have 0 live neighbors or 1 or anything but 3, basically?
Exactly. So like there is a fifth rule, which is kind of weird, like an unspoken rule, which is that if none of these rules apply, then the cell remains the same. For example, if there's a dead cell in the corner surrounded by dead cells, it just stays the same.
Mm-hmm.
Does that make sense?
Yeah.
So there, and besides, if we tried to compile this as is, Rust would actually, the Rust compiler would be like, hey, I don't think you've matched every possible case.
Oh, that's interesting that it wants you to.
Oh yeah. It's actively being like, no, we gotta be thorough. And that's why we're saying like otherwise, which is instead of matching a possible value for the cell, we're just saying like any other case, and an underscore. And we're going to return that same state. So we're saying like, okay, the value of next cell will be any one of these. Look, we're getting a hello from Horacio. Hey, Horacio, nice to see you. Thank you for joining in. We're doing a little Rust, a little WebAssembly, and a little JavaScript. Yeah.
So our first 4 cases in a language like Python, for instance, would be like an if, and then 3 if else's, and then the last one would just be else.
Exactly.
Right? That's the correspondence.
Exactly. So we're using this value because it's the current value of the cell, but this value, remember, which is the number of live neighbors, is not really relevant to what we're doing here. So if we tried to be like number of neighbors and we tried to compile that, Rust would be like, hold on, you're not using this. Why are you giving it a name? So what we're telling Rust here is like, we don't care about this. Yeah. And I see what Ashley's saying.
Cool.
Awesome. Happy to be here listening. Yeah, no. And hey, please join in. This is ensemble programming we're doing. So if you've got any comments, questions, or whatever, please feel free to chime in.
Absolutely a dialogue.
Yeah. So with all of that done, we can add our semicolon to say, okay, this expression is done. Oh, sorry. I'm done blabbling.
Let's see. Could you scroll the tutorial for me?
Of course.
Please. Thank you. Oh, yeah. bit that we need for this function is once we have finished assessing whichever cell we're looking at right now, we need to get the index for the next cell so that we can continue running through this loop until we have covered all the cells.
Exactly. Here we're saying, all right, for the next tick of the universe, set it the value of the cell to be the cell value that we determined from the rules.
Mm-hmm.
Cool. And
all right. So then when we have finished running through all of those cells and we know what their state is going to be on the next tick, the next generation, then we can call that next generation. Would that be the right terminology for Rust?
The next iteration of the loop. Yes, totally.
Okay. Oh, actually, wait, no. So I think I was misunderstanding. I was understanding the line 65, the next index equals next cell, that was calling the next iteration of the loop, but that line 69, self.cells equals next, was actually saying like, okay, we're done with this tick.
Yeah.
Let's get the next tick.
Yes. So what's mostly. I think okay. what's going on here is we're saying, hey, now that we've determined the next cell state for the cell we're currently looking at this row and this column, then we'll be like, all right, for the next universe, set the cell at this index to have this value.
Right.
Which we determined from the rules. What's happening in line 69 is once we finish looping through the entire universe, we will take our cells, which remember is our universe, and replace them with this new one that we've just calculated. The entire universe. So we just take all the cells, throw them out, and replace them with these new ones.
Right. Mm-hmm.
Does that make sense?
Yeah.
Awesome.
Okay, and so far we've been representing the state of this universe as a vector or an array of cells, but we want to make this human readable because that is an entire, so we're going to implement a basic text renderer. And so the idea is that we're going to write the universe line by line as text. And for each cell that's alive, we're going to print the Unicode character black medium square, and for dead cells we're going to print a white medium square. So like an empty cell will be the little white one that doesn't look like it's filled in, and then the filled cell will be filled in as a black medium square. And we're going to do that using the display trait from Rust's standard library. And so we're going to format a structure that's user facing. So this will be what somebody would actually see being displayed eventually, although that's going to have to get filtered through JavaScript as well, right?
Yes.
Yep. Okay. And so we're going
to use the use thing here, which is, I believe, the Rust equivalent of import. We're just going to be like, hey, let me use this FMT thing from the standard library.
Okay.
Doing some implementing.
All right. So implementing our format display. So we're not declaring display because display came from that standard library that we just imported. So we're just using it. And we're going to have a function, which we are declaring. We're calling it format, which is maybe slightly confusing because we just imported format, the format library, and now we're creating a function called format. I love. If I were teaching this course, I would say that this was a bad name. Anyway,
you hear that, Rust standard library? I love what the Karen H says here. When we are already looping through the universe, immediate panic.
For sure, right? Yeah. Like that doesn't sound like something we should do.
It'd take a while. Yeah, no. So I think this is I would consider this analogous to interfaces in Java
Mhm.
or in TypeScript as well, from my experience, where you're saying, hey, if something implements this trait, so yes, it's a trait.
Mhm.
What's most likely going on is Russ will be like, okay, then I expect you to implement this
Mhm.
format function.
Okay. Okay.
Sorry, I didn't mean to talk over you.
No, no, no. This is helpful because I don't know what we're doing yet. Right. Okay. Except I guess here's what I do know. So a display is a struct, which is roughly analogous to a class in Python. For people who don't have happy Python as their happy place, I apologize. Python is my happy place. And so I am constantly trying to map everything back into Python because that's what I understand
Totally
the
fair.
best. Right. So a struct is like a class in Python, right? And so in
Yes.
Python, we always have to, when we define a class, we always have to start with an initialize function. And so maybe if we are being required to make this function, that's maybe sort of roughly analogous to an initialize function in Python.
Yeah, I don't know if interfaces are a thing in Python.
I don't
Um,
think so.
but I would say, are abstract classes a thing in Python?
I well, maybe we're getting a bit too into the weeds here, but
Sorry.
yeah. So yes, I think I'm gonna go with this is roughly analogous to how we have to define an initialize function for classes.
Yeah, I think that works well. I think in a way it's kind of like we're saying giving it a super class. You know
Hmm.
how stuff can subclass, you can also superclass. You can also like that
Sure.
the class of which there is a subclass is the superclass of the subclass. I'm not
Absolutely.
going to say that again because I said it completely wrong and I apologize.
No, I think you
Um,
were good.
Thank you. So what we're saying here is once we declare that this is the superclass, it'll be like, okay, well, I've got this function that you need to implement.
Hmm.
And I will know how to interact with your subclass because I know you implement this.
Yep. Cool.
Yeah.
Cool. Cool.
So we have here. Um, we've got a function called format that takes one parameter, which is a formatter. Don't know what
Hmm.
that is yet.
Right. That must have come in with our import.
Yeah. See, exactly.
Yeah.
That FMT is from the import.
Right. No, I mean the oh right. Oh, what are those? So the two dots,
Yeah.
that's a is that like an assignment operator or an equivalence? I know we talked about this and I forgot.
I think
Sorry.
it's no. You're totally fine. Um, I think it's an accessor. For example, in our enum, right?
Hmm.
Let me go back to our enum real quick. We've got this enum cell with two possible values, dead or alive. So when we're accessing we want to access those possible values that are declared. We're saying go
Hmm.
into the cell enum and look up alive.
Hmm.
So for things like FMT display, we're saying, hey, go into the format module
Hmm.
and look up inside of it the display trait.
Hmm.
But it doesn't have to be traits. It can also be possible values for enums or structs. I believe formatter is a struct. Same
Okay.
goes for a result. Result is a struct.
Okay. Cool. Okay, and then we're going to do another for loop. So for every line in self.cells, I'm just going to read this to myself to make sense of it.
All
In
right.
self.cells as slice. So we're taking a slice of our array,
Yeah.
right? And what's defining the size of that slice?
I think that's where chunks comes in.
Chunks.
So
Okay.
so we're slicing up that array into
Yeah.
chunks that are width big.
Okay. Cool.
So each of those is a line, is a
Hmm.
row.
Hmm.
So we're saying like, okay, for each. So we've essentially turned our one-dimensional array and sliced it up into a two-dimensional one.
Right. So each row is going to be a slice, and we defined, so our chunks, let's see, our chunks were 4, right? I mean, our rows were of size 4.
I don't think we haven't defined one for our universe yet.
Oh, interesting.
We haven't hard-coded this yet. We will be doing that shortly.
Okay. Oh, maybe that was just in the example.
Yes, exactly. It wasn't the diagram that we saw earlier, which is, let me scroll up here. Exactly here.
Yeah.
Pardon me. Yeah, so we're going to loop through each line, and in each line, we're going to loop inside it through each cell. Cool.
And then we're going to define some symbols. So if our cell is dead, we're going to get that empty box. And otherwise, so we do have an if and an else here. We don't have to say otherwise. Then otherwise, we're going to have the filled in square.
A black medium square.
Yeah, a white medium square. My brain is like, no, that is clearly a green medium square.
Fair, honestly.
It really does not want me to say white. Yeah, and so I guess the reason here why we can just say else instead of otherwise is because there are only 2 cases, not more than 2. Okay, yeah.
Yes, this if statement can, in theory, be split up into multiple lines. It's done this way because I believe, I could be wrong, you're probably thinking, why not use a ternary? I think they're called ternary assignments, where you've got like let symbol equals cell dead question mark thing colon other thing. I don't know if you've seen those. I think those are in Python as well. I could be wrong. That's one way to do it, but I don't believe they exist in Rust. So we're using we're doing an if else statement in one line. I'm very sorry to be confusing.
No, that's fine. No, I was just thinking about previously when we had an if, we couldn't use an else, we had to use otherwise. But that was because our otherwise was covering like 7 other cases, not just one other case.
Exactly. So this isn't an
else.
This isn't a statement. This is we don't care what the value is. We could call this other state, for example.
Yeah.
Maybe that makes more sense. It's up to us.
Yeah, either way.
Cool. So we've got that symbol now.
And so then we need to write. And so this is actually looking a little bit like a print format statement in Python. We're going to bring in that symbol, and then we move on with our lives with okay.
Yeah. So we've
finished looping through.
Yeah, here we've written that symbol to the formatter. This is interpolating the string in Rust. We're saying like, hey, symbol represent yourself as a string and put yourself in here.
Cool.
So once we've gone through that line, we got here. We're writing against the formatter.
We need a new line because now we're going to work. We're outside of that interior loop, and we're going to move on to the next row. So we need a new line.
And then what we're doing here is returning that result. And results can have one of 2 values, okay or error, I think.
Oh, okay. Is this a bit like a built-in test?
Yeah, in a way. This is what a lot of I don't think we've done that here in Rust yet. What this does is prevent having null values. I could
Okay.
be wrong. I could be completely butchering this explanation, and I apologize in advance. But what we're saying here is like, do the thing, right? And the result, what this function returns is a result. And this can be this is kind of like a built-in try catch, if that's something you're familiar with.
Mm-mm.
So like accounting for whether something succeeds or fails.
Uh-huh.
So
Oh, yeah. Gotcha. We call them exceptions in Python. Yep.
That's
Try
it.
and
That's
accept.
it.
Mhm.
I think in Ruby it's called begin and rescue. Every language has their own way of doing it. Sorry, I don't want to make things more confusing. But yeah, so in Rust we're saying like, okay, take your result, that's why it's called a result, and wrap it up in this either okay declaration or error declaration. And then we can use match to be like, okay, if it's okay, take the value and do the thing. Say if you're requesting something from a server, it's really handy to be able to be like, okay, this request succeeded. Let's use the result. Or it failed and show an alert. Sorry, I didn't mean to go off on a tangent.
No, helpful.
All this stuff.
All right. So we have finished creating or working out our implementation for displaying our grid as a grid instead of as an array. And so now we need to create a constructor that will initialize the universe with an interesting pattern of live and dead cells, as well as a render method. Okay, so does that mean... All right, well, we'll go through it and see what it means. All right, so we're implementing our universe.
I'm sorry, do you know what, Laura? I just realized I've been doing this wrong.
Oh?
Yeah, I'm very sorry. I just realized that we've been implementing some functions for the universe, right? These are not exposed to WebAssembly because we don't have that Wasm bindgen thing here at the top.
Oh, so you have to do that for each method?
For each one that we want to make public.
Interesting. Okay.
So what I'm going to do, because this tick function is going to be public. It's something that we're going to be able to call from JavaScript. So in actuality, what I need to do is take this, just going to remove it, and do a separate impl statement. But with the top here, say like, hey, you can use this in JavaScript or wherever you're calling this from in WebAssembly. So by saying Wasm bindgen, we're saying like, hey, you can be used outside of Rust.
Okay.
If that makes sense. And here we can also add that that constructor. So it's a function called new. Takes no parameters and sorry, I'm much.
No, that's fine. I'm just sort of orienting myself. Okay, so we're putting all of these what you just moved. Sorry, can you walk me through what you just moved into where?
I'm sorry, I kind of went too fast there, didn't I? So what we've got two functions here: get index and live neighbor count. You might have noticed I didn't put pub in them.
Right, because they're not public.
They're not public, and by extension, they're not going to be used in Wasm in WebAssembly. However, these functions, making a new universe and doing the tick, are going to be accessed or called from outside web. Well, from the interface that's interfacing with WebAssembly.
Okay, so we have two implementations of universe. Is that correct? One that contains public functions and one that contains non-public functions or methods?
I would say it's cumulative. So they're not separate implementations. They're just part of the same implementation. Maybe.
Okay.
So, here,
we're declaring implementations twice though, right?
3 times if you count the display one.
Cool.
So we're saying here's 2 private functions in the implementation of the universe. Here are some public functions in the implementation of the universe, which also bind to Wasm.
Okay.
And here we are implementing the display trait for the universe.
Gotcha. Okay. Yeah, that makes more sense.
Cool. Thank you for catching that.
Oh yeah, no worries. It's the gift of the complete newbie, right?
It is absolutely a gift. Like calling things into questions is so critical when it comes to learning, and something I wish I did more.
Okay, so in our public implementation or our public methods for our universe implementation that are associated with that Wasm bindgen, we're going to have our function, our public function, which is new, and it's going to make a universe with. Okay, so why are we defining the width and the height to be 64 when in all of the other places we're allowing them to be variables, not constants?
Yeah, that's a good question. So what we're doing here is essentially hard coding the width and height
Yeah.
of our universe to be 64 by 64.
Yep.
If we wanted to make this more variable, we could, for example,
Mm-hmm.
add parameters. So this function new, right?
Mm-hmm.
This is the constructor, and it takes no parameters, and it returns a universe.
Mm-hmm.
So we could have width. I'm about to mess. I think it's width. Actually, I can take a look at our declaration of that struct. Sorry, I'm all over the place. If I scroll up here, we can see the declaration of our universe struct, which
Mm-hmm.
has 3 properties
Mm-hmm.
or attributes. I don't know what the term is here, but it's one of those 2.
Right.
We've got a width, which is of type U32, an unsigned 32-bit integer. We got a height, that's a U32, and we got cells, which is that array of cells, a
Mm-hmm.
vector, which is
Mm-hmm.
an array. Yeah. So we could, for example, have width U32 and height U32 and have it be done that way.
Mm-hmm.
That way we don't have to hard code it.
Right.
For the purpose of this exercise, we are hard coding it. I don't think there's a specific reason per se.
Okay.
What do you think? Shall we go ahead and go outside of that?
Maybe let's do that as an extension. Like we'll get the base case working and then
Love it. I'm with you. I've declared
Right.
those hard-coded values.
Yep. Okay. And so then we're going to let our cells be, okay, get a value of 0 dot what?
Yeah. So what we're saying here is, sorry, I've done that wrong. So what we're saying here is, give me an array or a vector that is a range between 0 and width times height. So every number between 0 and 64 times 64.
Okay. And is this
Does that make sense?
exclusive range? Because otherwise it would be one too big.
It is an inclusive range. No, you're probably
Because wouldn't that be 69? And well, not 69. It would be 0 to 64 by times 64, but that would still be one too many.
Yeah, you're absolutely right. So this would be from 0 to, and I'm just going to do this in the way that I know best. I'm going to start up interactive Ruby and run 64
times 64 minus 1.
Right. So it'd be 4,095.
Yep. Okay.
So so that's an array of every number between 0 and 4095. And then we're going to call .map. What this is going to do here is call an anonymous function that will return an array.
And this is anonymous in the human sense, right? It's anonymous because we're not giving it a name.
Correct.
Good.
Here's my % sign there.
Right. Okay. So, and that was our index, you said?
Yeah, that's Right. That's each number in that range.
Yep. Okay. And so if I mod 2 is equal to 0, so if this number is a multiple of 2, or if this number is a multiple of 7, then we have some stuff to do. But previously, we used a single pipe as an OR, and that was an inclusive OR. Here we're using 2 pipes.
Do you remember where that was?
Yeah, I think that would have been in where we were implementing the rules. Yeah, there it is on line 77.
Yeah. I think this is different from a I think this is it is one pipe, right? It is one pipe. And I think this is down to the syntax of the match statement. So we're saying this pattern or this different pattern.
Okay. Okay,
But
so inside a match statement, OR is 1 pipe, and outside of a match statement, OR is 2 pipes?
I think that's the fairest way to look at it. Yeah.
I don't love that, but okay.
I'm sure there's a perfectly good reasoning for it, and it might have to do with like bitwise stuff that I'm quite frankly.
I was wondering whether like clearly the first one where it's 1 pipe is an inclusive OR. I was wondering if the double pipe is an exclusive OR, like only one of these.
Oh, that's what
can
you
be
mean.
True.
No, I'm because for example, I think if it's 14, then it would work as well.
Okay.
Yeah. No, I think and I'm sure do you know what? Let's maybe do we have time for a tangent?
I want to know, man.
Let's do it. I love it. Let's look it up. Let me make this bigger. Cool. Can I hide this? Yeah. So Rust. Oh, sorry. I kind of went too fast. I'm going to go into the Rust book. Match expressions. Is this correct? I think this is correct. Yeah. So let's look at it. Expressions on a pattern, an example of a match expression. So we can see different types of matches here. So for example, we're matching X, and depending on if it's 1, it does this. If it's 2, it does that. And if it's anything else, it prints out something else, right? Multiple match patterns may be joined with the pipe operator. Each pattern will be tested in left to right sequence until a successful match is found. So it's kind of an OR. And I guess there's not really a reasoning for it. Sorry, I got a cable blocking me there. Every binding in each pipe separated pattern must appear in all patterns of the arm. Every binding of the same name must have the same type. And
oh, you know what? Our faces are on top of the text that you're reading right now.
I'm sorry, folks. Silly of me. Thank you for catching that.
Sure.
Is that a range pattern? Yeah, every binding in each separated pattern must appear in all of the patterns in the arm. Every binding of the same name must have the same type. So it's not really saying why. Multiple match patterns may be joined with the pipe operator. Each pattern will be tested in left to right sequence until a successful match is found. So
that is inherently an inclusive OR.
Right.
Yeah.
Right.
I guess then the question is, what are double pipes in Rust?
So I think it's not so much about, well, I mean, let's find out. What would that be?
Conditionals? Do we have?
Ooh, conditionals. Here we go. If let, no. So patterns are definitely using a single pipe operator.
Okay. So I guess that's really what it is that it's a pattern thing.
The expression cannot be a lazy Boolean operator. Ooh, I think we found it. Use of a lazy Boolean operator is ambiguous with a planned feature change of the language. The implementation of if-let change seems blah, blah, blah. When lazy operator expression is decided, this could be achieved using parentheses as below. So that's it. Lazy Boolean operator expressions. That's what these are. The double.
Logical.
Okay, so they're lazy and eager. Check it out. The double pipe operator denotes the logical or, and the double and operator denotes the logical and. They differ from single pipe and single ampersand in that the right hand operand is only evaluated when the left hand operand does not already determine the result of the expression. That is, double pipe only evaluates its right hand operand when the left hand operand evaluates it false, and double and does it if it's true. So in short,
Lazy and yeah, that's a lot of adjectives for and very enthusiastic adjectives for things that are not in fact animate.
Coding, yeah, I love what Karen H says here. Coding is so much fun. They are lazy and eager. Yeah. So what's going on here is with the single and so this is, I'm really glad that we went down this rabbit hole. So the single pipe will say, we must check every one of these, right? Whereas with the single pipe, with the double pipe, it'll say like, you can stop here if this is true.
Okay.
Does that make sense?
Okay, so the double pipe is kind of an exclusive OR in the sense that if the first one is true, we're never going to look at the second one.
Yeah, because that OR statement is fulfilled.
But if the first one, so it's not exactly an exclusive OR. It's like,
no, because
interesting.
If you wanted to do an exclusive OR, we would need to check all of them to make sure that only one of them is true.
Yeah. Interesting. Okay. I'm going to have to wrap my head around.
I'm going to put a link to this in the chat as well. I think it's interesting. Thank you so much.
Yeah, this is fun.
Yeah. Cool. Shall we
okay. Yeah.
Come back here? Yeah.
Come back to where we were. Right. Okay. So if our number is a multiple of 2, or if it's a multiple of 7, then that means that cell is going to be alive.
Yes.
And if anything else is true, then our cell is going to be dead.
Mm-hmm.
I still want to play with why is it 2 and 7, but I'll do that on my own time. Okay, and so then once we've finished mapping all of these cells to being alive or dead, then we're going to collect them all.
Yeah, I think collect
is that a
here,
rest function?
That is definitely a rest thing. I think it turns it from an iterator into a array. If that makes sense.
Yeah. Okay, wait, but what we did a second ago was we got it out of an array, and we put it into a grid, and now we're putting it back in an array?
Yeah, I think map may not return an array. Is my guess. Map. Here we go. Map Rust. Nope, that's a Rust. Oh, here we go. The map iterator implements double-ended operator. So it returns a map.
Yeah.
And if we want to turn that into array, then we need to call collect. Let me see if I can find collect. Transform an iterator into a collection. So I think this is essentially doing typing stuff.
Okay.
So it's very we're taking an iterator type.
Mm-hmm.
And we're saying, okay, we're done with that. Let's now turn it into an array.
Okay, and then we're going to pass this array into our turn arrays into grids thing that we just made, or?
Yeah, we've collected our array into this variable cells.
Mm-hmm.
So now we've got our cells that are, if they're at index that is multiple of 2 and 7, it'll be alive. Otherwise dead.
Mm-hmm. Oh, I just realized where the 2 and the 7 come from.
Oh yeah?
Doesn't matter. That's where they are the interesting pattern of live and dead cells.
Oh
That's
yeah.
how we can make sure that it's not boring, because 2 and 7 don't have too many common multiples. They're two primes, a little bit spread apart, but not so huge that we're going to be getting ridiculous sizes of things. Oh. I was trying to make it make sense with the 64. And I was like, okay,
No, but
7 and
this
64
is
really don't have anything in common.
Oftentimes, like, but it's probably, yeah. So I guess it's just a randomly chosen number to look.
The comment is, this is all that this is doing, is making it interesting. I gotcha. Okay.
Right. And then we're gonna, sorry.
Yep. And then we're going to, so our universe is going to have its width and height and cells like we defined previously, except we said a vector of cells, right? Yep, an array. But our cells have now been, our cells are a vector. That's what are an array. That's what that collect did at the end of our let statement. Okay.
Exactly.
Cool.
Exactly.
So building a universe. Isn't that a Sarah McLachlan song?
Building the universe?
Isn't it?
Laura, I have to admit, I am so bad at song names. Like, I'm so bad.
I think that there's a Sarah McLachlan song for this that is now the soundtrack for this game.
I love it.
Anyway,
I love it.
Sorry. Okay, and then if you can scroll up for me, because our
yeah, of course.
There we go. Thank you. Okay, so we have a function that is going to render our self. So in this case, our self is that universe, right? Is that right?
That's correct.
Okay. And it's going to be rendered into a string. And this is why we need an array, so that we can make a string out of it, because arrays map very nicely into strings, is the way that I'm explaining this to myself anyway.
I believe this is where that trait thing comes in.
Mm-hmm.
So calling toString on this, that's where Rust takes over. It's like, I gotcha. I can do all my funky display trait stuff, and consequently call that format string, that function we implemented. It enables us to be able to call toString on our universe to then let itself be rendered as a string.
Right. And that's going to be helpful for JavaScript, I think, right? Eventually.
Exactly.
Yeah. Okay, cool. And so we have now implemented our Rust game of life, and we need to recompile it to WebAssembly by running wasm pack build within the wasm game of life directory.
Something failed. Let's have a look. Very likely a typo. So let's see. Lib source line 40. Oh, sorry. I'm I don't know if you knew this, by the way, Laura, but I'm still learning VS Code. But if you hold down Command and then click, it takes you to the line where the error is.
Yes, and I think that if you do it with a link, it actually opens the link.
That's handy.
Yeah,
that's really handy. Sorry, yeah. So we've got an error. Shall we?
Yeah.
So let's see what we got. Unexpected token open bracket. And here I'm doing count plus equals self dot and then accessing in the array. And I think what's missing here is cells.
You know, error messages, they're only somewhat helpful.
Yep.
Right? This error message is like, I'm mad because there's a bracket here. And in reality, it's like, I'm mad because you didn't say which array you're talking about.
Well,
those aren't the same thing.
That's kind of it, isn't it? Because like we've got self dot and then access. So this is already a syntax error. Like I shouldn't be calling it, like if anything, I could be doing this, and then I'm trying to accessing something in self, but self is not an array. It's a universe. So that gives me the idea like, hold on, I was trying to access something and I forgot what it was. So the only thing that could be in self that is an array would be cells. Let's give it another try.
Yeah.
We got a function, we got a warning here, which we've seen before, and that's totally okay. And there's
what does that mean again? Or it means nothing, because panic hook, that sounds like a problem to me.
Let's have a look. It is in here. So we've declared this function, set panic hook, and Rust is saying like, hey, you're not using that.
Oh.
So, and it's telling us like, hey, I've got this compiler setting called warn on dead code being code that I never run, on by default. So it's like Rust is just being like, hey, I noticed you declared this thing, but you're not using it. And it could be that Wasm is using it. I could be wrong. Maybe it's something we're going to find out as we go further in the tutorial. Because we were confronted with it in part 1 when we... Yeah.
Okay, cool. So, to be continued, I suppose.
To be continued. So our Wasm package is ready. So... sorry. Feel free to... Oh, let me scroll. Yeah.
Thank you. Okay, so now we're actually going to render this with JavaScript. So we're going to add a pre-element to our Wasm game of life, index.html.
Which is in here.
Okay. What is a pre-element? Sorry.
No. This is good. What is pre-element? I think if chat, if you know, like, please feel free to chime in. This is one of the many reasons I love MDN web docs. So the pre-HTML element represents pre-formatted text, which is to be represented exactly as written. So it's like, don't let the formatting of HTML take over, but rather just display that text as is.
Gotcha. Okay, I would never have gotten there on my own. So I'm glad that we looked this up.
The text is typically rendered using a non-proportional monospace font. And I believe that's how code blocks are represented.
Yeah.
Using it. Yeah. So you can see there, it's like, we've got this and it's got a fun pattern. And then in the output, it's, I don't know what, I see some French, I think. I don't know what's going on here.
And Karen H saying that it's like a code block, but inline. Yeah, maybe.
Oh, yeah.
Yeah.
It's like a code block, but inline. Yeah, thank you. I love it. Yeah, so we're going to probably be using that to represent our universe. So I'll go ahead and add that. Okay, that's done.
All right. And then we're using a script source. We're using Bootstrap. Okay. And so then next we want to center that pre-element that we just created in the middle of the web page. And so we're going to use CSS Flexboxes, which I don't think I've used previously.
Oh, really? I love CSS Flexboxes. We're gonna love it. Like, we're gonna play around with it. It's gonna be great.
Okay, cool. So we're going to add a style tag inside the head of our index.html.
So I'm going to write this out. I like typing out CSS.
So this is interesting to me because when I have used CSS previously, it was in a separate CSS file, not declared within the HTML file itself. Oh, bye, Horacio. Thank you for joining us.
Good to see you, Horacio. Take care. Sorry, you were saying
that previously when I've used CSS, it was in a separate CSS file, not, it would be like, something.css, not in an HTML file. So this is interesting to me.
I would argue that this is not necessarily a best practice, but rather a simplicity in order for us to not have to mess around with importing files.
Mhm.
But most of the time you would be packaging up your CSS in a separate CSS, or sorry, writing up your CSS in a CSS file.
Mhm.
So we're making our body position absolute, setting it
Mhm.
at the top left, making it stretch and fill up the whole window.
Okay.
Display flex, so it's a Flexbox.
So how does giving an absolute position and a width and a height of 100% allow for flexibility? Although I guess this isn't like a CSS class.
No, but it's a good question. I mean, that's what these that's why this is a live stream and not a
Mhm.
a tutorial. um, so I would argue it doesn't. And quite frankly, if I wanted to have a div stretch out to the entire screen, the way I would do it is not by making it absolute. I would make the HTML and body have a width
Mhm.
and height of 100%,
Mhm.
and then put a Flexbox inside the body, so that
Hmm.
elements inside, because the elements inside it then conform with those Flexbox rules.
Mhm.
So we're saying, hey, inside the Flexbox, which is the body, remember,
Uh-huh.
anything that's in there will be inside. So I am a flex. Sorry, let me go take a step back. So this is the body saying I am a Flexbox.
Mhm.
I put things down in a column, like everything is below each other,
Mhm.
and everything will be center aligned, and as they spread out, they'll be like along the center.
Okay.
Sound good?
Yeah.
But good that we check. Up.
Okay. And so then at the top of our Wasm Game of Life index.js, so we're looking at a JavaScript file. We're going to fix our import to bring in the universe instead of the old greet function from live stream number 1.
This is exciting. I mean, I've always wanted to import the universe.
That really does sound dangerous to just like looping through the universe, like Karen H said.
Yeah.
Mhm. Okay. And
I hope the size is okay, by the way, folks. Like, if it's too small, like, please let us know.
Mhm. Okay, so we're importing universe from Wasm Game of Life. Oh, we need to maybe change the from statement because we've
Oh.
got from Hello Wasm Pack.
You're absolutely right.
Okay, and we're going to get that pre-element that we just created and instantiate a new universe. Element by ID. Cool.
This always amazes me because it feels like I'm doing magic. The fact that I'm calling what is essentially Rust from JavaScript is mind-boggling to me.
Right, but it's filtering, right? Like we're actually calling it through the Wasm bind gens. Is that right?
That is
Yeah.
absolutely correct.
Okay. So
Which
we've got
is,
that Wasm buffer between our Rust and our JavaScript.
yeah.
Cool. Okay. Do we still need that wasm.greet on line 7?
I think we can get rid of it.
Okay, so this JavaScript is going to run in a request animation frame loop. Don't know what that is, but okay. And so on each iteration, it's going to draw the current universe to the pre. That syntax is interesting to me. It's drawing it to the pre-element, not in the pre-element or with, but to.
Yeah, so we've got a function here called render loop, right?
Mhm.
And inside there, we're saying, hey, change the content of this pre-function, of this pre-element,
Mhm.
to be the representation of the universe as a string. That's where that render
Mhm.
function we defined came in, remember?
Mhm.
Yeah. So it draws the current universe into the pre.
Into. Gotcha.
Yeah. Yeah, exactly. As a content of that pre element.
Mhm. Okay. And then we're going to call our universe tick. So we're going to get our next iteration, our next generation of our universe. Does case matter here? Oh, I see.
Yes. Yes, because this is the universe
Uh-huh.
struct.
But we created our lowercase universe. We
It's a
declared it
variable.
as an instance of a universe. Gotcha. Mhm.
Yep. Exactly.
And then we're going to request our animation frame. And to that, we're going to pass our render loop.
Yeah. So we're declaring here a function that says render the universe, do the tick, and then request animation frame, which I've got here. Tells the browser that you wish to perform an animation and request that the browser calls a specified function, which is the render loop one here, to update an animation before the next repaint. So we're just saying like, hey, keep next time you're ready to call something, next time you're ready to render, do this for me.
Okay.
That makes sense?
Mhm.
So every time we render, every time we render the loop, we queue up another one to be rendered.
All right. Yeah, and that makes sense. It makes sense that there's no end point.
Yeah.
That there's no end time because this can just run as long as we have an attention span for it, I suppose.
Yeah.
Okay. Right. So then we're going to start that rendering process by making an initial call for the first iteration of the rendering loop. And so this is the one that's going to generate that grid based on that interesting pattern, right? With multiples of 2 and 7. Gotcha.
Exactly. So we'll say like, when you next animate. So right when we load the website, call this function.
Mm-hmm.
And inside that function, we recursively say, hey, by the way, next time you animate, do that. So it's doing it infinitely.
Mm-hmm.
Yeah, so that's done. I'll go ahead and save.
Okie dokie. And so we're going to make sure our development server is still running. So we're going to run npm run start inside our www directory. Oh, okay.
Can't resolve Wasm Game of Life. Inside. Oh, could it be I need to, because I've never actually run this. Could it be I need to npm install?
Oh, I remember from last week, GitHub wasn't working when we were streaming. And so it seems to me that you were bringing in just the one page that we were going to be, or one file that we were going to be working on.
Oh, that could be. Actually, let me look at package dot. Oopsie. Look at package JSON, because I believe could it be we didn't. Where's that dependency? Dependencies. It's called Hello Wasm Pack.
Mm-hmm.
We call it Wasm Game of Life. Maybe Hello Wasm Pack was the right one all along.
But universe isn't in Hello Wasm Pack, is it?
I think it is.
Oh.
Let's give that another try.
Okay.
I think that could be why it's failing. See? Universe was not.
Yeah, I don't think it is there.
Huh. Maybe I am wrong. It's entirely likely. Universe was not found in Hello Wasm Pack. Let me try running it first, and then we can debug. Does that sound good?
Sure.
So that's done, which means we should be able to open it from localhost 8080. See what happens. It'll be empty. And if I say, there we go.
Oh, I think that your console is covered by our faces.
Very likely. Let me hide our faces for just a second.
It's a smidge tiny as well.
Yeah, I will make that. Thank you. I'll make that bigger as well. And I think I can do it like this.
Yay.
That size is okay. So error importing index.js type error cannot read properties of undefined reading new. So yeah, universe was not found in hello wasm pack, as you correctly said.
Okay.
So I'll just bring our faces back and see, maybe we missed something in our implementation of life. So what I would do here is we've got our wasm bind gen. Let me just take a look at our librs again and see where we've got. We got wasm bind gen here. We got our wasm bind gen pub struct universe. And it's very likely that, as you correctly said, that it's called something else. So, because we created our, hello wasm pack is absolutely right. It is wasm game of life, isn't it?
I think it should be.
Yeah.
Because I think that hello wasm pack was what we were using to do that greet function.
Yeah. You're absolutely right. Sorry, I completely misunderstood that.
No worries.
So, because we've got our PKG here, this is our bundled up wasm, and that is called wasm game of life. So what we need to do is go back to our package.json here and fix that. So this should be dependencies hello wasm pack, and that would be oh, I need to integrate it.
What does that mean?
So do you remember when we did our hello world, right? But we couldn't commit that npm packet, that www folder, remember?
Yeah.
So what we did was at some point, JavaScript bundler, using our local wasm game of life package in www. This is what I forgot. My bad. We need to add this line.
Cool.
Sorry, I was completely all over the place there.
No problem.
Or that. Okay.
Okay, cool.
So now I'll do another npm install. npm I is also a way to do npm install. Okay, so now we've integrated our wasm game of life. And if I go back here, it's wasm game of life. Perfect. npm unstart. Now it's compiled successfully.
Yay!
So
we're gonna go to our local. Yay! Look at what we have.
Look at that. That is fast.
Yeah. Oh, okay. It took a while. I was watching one that had one little bit of a grid that had never changed. It took a long time in terms of how many generations to change it. So
and this is interesting. Now it's stuck. Now what's interesting is if I refresh that, it'll start over, which is good. And this is all text we're looking at.
Yeah.
Which is super funky. I love looking at this. So what we can do, so we've got a couple of options for stuff we can do. So this is our implemented game of life, which is 64 by 64. Now, if I recall, Laura, you had an idea on how we could tweak this.
Yeah, we could extend it by allowing for maybe, could we even have it be a user defined width and height?
I think so.
It does need to be a square, right?
Not necessarily. Not necessarily, because our rules apply in a rectangular
Yeah.
universe as
Okay.
well,
Okay.
which is a weird thing to say.
Flatland.
I gotta unpack my copy of Flatland.
Mm-hmm.
Yeah, so I would say, if I may recommend, let's change our Rust code to allow that extensibility, and then we can work on the front end.
Cool.
Yeah.
Yep.
So please
Sounds good.
feel free to guide me.
Okay, so let's see. Where did we do? We hard coded that 64 by 64 somewhere in our implementation. Yeah, in the public method. All right, and so you were showing a little bit ago how we could pass some arguments to the new function.
So, for example, have the width and the height,
Yeah.
like this, and eliminate the need to have those hard coded.
Mm-hmm. And before you were defining what, or you were letting in your, when you were passing them as arguments, the width and the height, you were saying that they were U32s. Do we need that?
Yeah. Rust is gonna, like, I can show you what happens. So right, we've got it now as width and height.
Mm-hmm.
If I do wasm pack build, it will fail.
Mm-hmm.
And I find Rust to be helpful when it comes to this,
Okay. Yeah.
because it's saying,
It's
like,
telling us it wants a type name.
yeah,
It was
expected
lower
one of,
down, maybe.
yeah, here it's saying, like, hey, I was expecting a colon or one of these or one of these, but we found a comma instead.
Mm-hmm.
So so the colon will say, like, what type it is.
Yep.
And we can infer from the declaration of the struct that it's a U32. We can do it this way.
Nice. Okay.
We could even no, one step at a time. One step at a time. I've got another idea for something we could do. So that's done.
Okay. So now where are we going to get that input?
So what we definitely would need to put that here when we declare our new universe.
Mm-hmm.
Shall we try hard coding it first and then asking the user for it?
Mm-hmm. Yep.
So we could do sorry, I'll let.
Oh, right. Okay. So here, so we can just, so we're in JavaScript land now.
Mm-hmm.
And so we can say, do we need to pass the width and height variable names, or can we just put it in as a list?
Yeah, it's an argument list.
Okay. All right. So what's your favorite number?
My favorite number is 4.
What's your second favorite number?
That's often. Let's say 16.
Okay.
So with that saved, I can start up the server again.
Mm-hmm. All right, so we have a 4 by 16 situation here.
Yep. And did you see what happens every time I refresh? So we've got but all of the ones that are divisible by 2 are there, but they're immediately dying.
Yep.
So that's okay. I think that
Sure.
means it's working.
Yep. Working as intended. That's better.
Yeah. So what if we I think it'd be good to ask the user, like you suggested.
Mm-hmm. But we would maybe need to provide some instructions about what kinds of numbers will produce interesting results.
Yeah, what I'm thinking of is using the prompt.
Mhm.
The prompt function in JavaScript where we could be like const width equals window.prompt, and there we would be like enter width. I don't know what default is, but it's optional. We'll leave it as that. Oh, the default value, silly me. The value would be 64. Okay.
Why are you choosing 64 as the default?
Just based on the previous example.
Okay.
Like
Works for
no,
me.
no other reason. Height would be the same thing.
Okay.
And width and height. I've actually never done this in JavaScript, so I don't know how it's gonna look.
Ooh.
Oh, it's kind of small, and I'm afraid I can't make it bigger. At least I don't think I can. No, I'm afraid not. But yeah, it says enter width and then 64 by default.
Mm-hmm.
So let's make that 72.
Okay.
Entering a height. Let's make that. Sorry, I've been picking all the numbers.
91.
91. That was interesting.
Mm-hmm.
Did you see it kind of flashed for a bit?
Yep.
So these are all staying the same, or they're yeah.
Mm-hmm. That's because, at least I think it's because I chose 91 because it's a multiple of 7.
Yeah.
Yes, I wonder. Let's try a different one. Let's try 49 instead of 91 and test the this is because it's a multiple of 7 hypothesis.
Okay. What should I pick for the first one? Sorry.
For the first one, I guess it doesn't matter. Even 64 is cool for the first one, but for the second one, if we do 49 for the height, sorry.
Oh yeah. So it doesn't matter for the first one, so I'll leave it at 64, and the second one will be 49.
I mean, we could do it the other way around too, but yep. Okay. So if we fix one of the numbers as a multiple of 7, we get something very boring very quickly. Does it work the same if the width is? It should be. If we swap those, we should end up with a
49 for the width and 64 for the height.
Yeah.
Whoa. Yeah, you were right.
Very boring very quickly. Yeah. So 64 is a multiple of 2, and 49, of course, is a multiple of 7. So maybe we want to provide some guidance to the user.
Mm-hmm. But you know what I was thinking actually was why not make these variable as well?
Ooh. Okay. Just like random.
Random, for example.
Mm-hmm.
So how could I do that? DuckDuck. I'm gonna search for DuckDuckGo. Random number between 1 and 2 in Rust.
Oh, I thought. Oh, yeah, gotcha.
Sorry, I hope that makes sense.
Yep.
Sorry, sounded like you wanted to say something.
I was wondering for a second why you chose 1 and 2, and then I decided that it was arbitrary.
Yeah, to make it either like make it random whether they're alive or dead. Does that make sense?
A random number between 1 and 2, though?
Gives it a 1 in 2 chance of being alive or dead.
Okay. Oh. Okay. So in Python, the random function is an exclusive range. So if you put between 1 and 2, you would only ever get the number 1.
Right.
But maybe this is an inclusive range.
Mm-hmm. I think we need to define that.
Oh. Okay, wait, use rand. Okay. You mean we can define whether it's an inclusive range or an exclusive range?
I believe so.
Because I would have thought that would have come with the random whatever we're importing it from or using it.
In fact, I believe even that it's because it depends on this rand external module or crate.
Yeah.
And that lets you define, let's see, to get a random. So a lot of applications require random numbers. A very popular library in Rust to generate random numbers. It supports a wide variety. For more details, you can read the Rust Rand book. Yeah, I was thinking either let the user pick ones or just go randomly.
Mhm.
What do you think?
I think it probably makes sense to let the user pick the width and the height,
Okay.
or at least we could, well, no, I mean, so this is sort of like a random seed. Yeah, so I guess we could tell the user, you can also choose a random seed effectively. Okay.
I think it'd be fun to try.
Mhm.
Cool. So let's do that. So we'll need extern crate rand, and
What is crate?
it's the Rust equivalent to package,
Oh, okay.
or what are they called in Python? Are they called libs, right? Libraries.
Uh-huh.
Yeah.
Cool.
In Rust, they're called crates.
Mm-hmm.
Now, I believe I'm going to confirm that just because I think I need to declare using that. Yes, exactly. I need to declare this as a dependency of our
Okay. Our package.
So if I go here and I go to cargo toml and I will add a dependency of rand.
Mm-hmm.
Yeah. It's done. And then I can just use it. What about generating a random number within a range? For that, you'll need to create a random number generator and call its genRange function. So this is a random number generator.
Mm-hmm.
And here we're declaring a number that's between -10 and 10.
Mm-hmm. So, and then we're printing that it can be from -10 to 10. And so I am assuming that this would be an inclusive range, unlike in Python.
Yes.
Mm-hmm.
That makes sense.
Mm-hmm. Okay.
Yeah. Yeah, let's give it a try. So I will import these functions. So then when it comes to, just going to hide this. So then when it comes to here.
Mm-hmm.
So instead of doing this, if we say, we need to first declare our number generator.
Mm-hmm.
And if that generate range between, let's say 0 and 1. So a random number between, like a random integer between 0 and 1.
So either 0 or 1.
Exactly. Is equals to 1. Then it'll be alive. Otherwise, it'll be dead.
Okay.
Sound good?
Yep.
So let's wasm pack build. So now it's going to install. The reason it's taking ever so slightly longer now is because it's installing that random crate.
Right.
The rand crate, not a rand. Sorry.
Yeah.
So I'll go ahead and start up the front end. And let's, whoa. What's going on here? Oh, what did I write? I wrote npm start run and it should be npm run start. My bad. There we go. Let's give this a refresh.
Okay. So if we give it exactly the same values, so the width 64 and the height 49, we should now get something that is actually interesting, right? As opposed to what we had before.
We got nothing.
That's fun.
Importing index.js. Runtime error unreachable. Unreachable.
What does that mean?
I'm not sure. Can I debug this? No. So somewhere in our universe new function,
Mm-hmm.
and I'm guessing it has to do with the fact that we did this here.
Mm-hmm.
Something didn't work. So RNG generate. Let me take another look at that. I'm going to try something else here, if I may.
Mm-hmm.
Let x of type U32 equals, and do that here. Whoops.
Okay.
Just to kind of tell it explicitly, hey, we want this to be an integer.
Mm-hmm.
And if that random number is equals to run, then we'll set it to be alive. Otherwise, it'll be dead. Maybe it was just not very happy with our implementation. To be honest, I'm not sure why that happened, if I'm honest with you.
Sure.
So npm run start. It's done. Let's give this another try. So I'm still getting the same error. So I'm going to try. Maybe.
Where are we using that I? Okay, so that's an index, right?
That's it. We're not using the I anymore. We can leave it blank as an underscore.
Okay.
Good call. I still want to try, if I may. Rust rand inclusive range. I just want to be safe here. So just want to see how it works to generate a random number, you know?
Mm-hmm.
Oh.
It is exclusive on the end. If you look at the
Oh, sorry.
maybe scroll down.
Oh yeah.
Was the top answer. The beginning is inclusive and the end is exclusive. The same as in Python.
That's it. No, you were right. So we got a
2.
that here.
Yeah.
So that way it'll be either 0 or 1.
Mm-hmm.
Thank you. Awesome.
Sure thing.
npm run start. Let's see how that goes. So still getting that unreachable error. And I don't know why. If random number is equals to 1, what does unreachable mean? Huh.
Could we search the runtime error unreachable?
Yeah. Wasm pack error unreachable. Why does a properly functioning Rust library fail with unreachable code error when compiled to Wasm using Wasm bindgen? This looks good. Not all parts of the standard library are implemented in the started Wasm target. So it's got to be the random number thing. So it could be that this rand crate might not be fully compatible with Wasm.
Okay.
Wasm Rust rand. Yeah. Yeah, I wonder if this is it. Ah, there it is. See? So this person set up rand and the thread RNG, which is the one we were using. And if you see here, executing test function in JavaScript results in a panic. There it is.
And look at that. It turns out that there's a cargo.toml thing we can do.
Configuration was wrong and I missed the rand RNG in my source code. The following is correct in cargo toml. Interesting. So we needed to very specifically tell it like, hey, I want the Wasm bindgen feature. Let's give that a try.
And this person closed their post with, sorry for wasting your time. This issue can be closed. And now I want to go in and comment and be like, you saved us time. Thank you.
Absolutely.
Expected and equals found a comma.
Yeah, that was my bad. I forgot to put version here. I wonder what people said. Yes, we require specification of a feature flag for Wasm. Note that if you're trying to reproduce it using only the feature's been renamed to JS, so you need to have. Let's give it a try.
Yeah, let's see what happens.
By the way, I realize I've kept you much longer, Laura. I hope you don't mind.
All good.
I say we see it to this. We see this to the end, and then call it a day if that sounds good. 64. Hey, there it is.
Yay!
So now it's randomly either making it alive or dead. So if I remember, there was like a couple of these here. If I were to go back and start it up again. Oops. Oh, there we go. Now it's moving slightly differently.
Let's try it just for fun with the sevens and the
Sure
twos.
thing.
Well, we've got twos, and we can just reassure ourselves that it's going to work with.
Yeah, but you see
odd
now,
numbers.
And now you can see that the infinite state is different, which is good. That means it's randomly working. So you said 49 by 91?
Sure.
Yeah.
Yeah. So there's no reason at all that sevens should have anything to do with anything. Yep. Okay. Good.
It's kind of beautiful. It kind of looks like little explosions.
Oh, they look like little fishies to me.
Oh, yeah?
Yeah.
That's interesting. I wonder what that says about me.
It's a Rorschach, I guess.
That's fun. Cool. So I'll tell you what. Now that we've got this working, let's go ahead and commit this. And then I'll go ahead and create a pull request. So cargo toml and src. Implement life, make it randomly start. Oh, sorry, this is not a conventional commit. Feature. Does that look good? Now, this is yours, so I can't really push to it. So I'm going to create a pull request.
Okay.
But we don't have to do that live now. So I will say, unless there's something I might have missed.
Not that I know of.
Oh, in that case, I would say, let's go ahead. Oh, I just realized our faces have been in the stream for a while. So I will just go ahead and say, that was great fun.
Yes.
Thank you so much for joining me, Laura.
Thank you for having me.
Yeah, this is always a joy. I would say, let's come back and make this in the canvas sometime.
Definitely. Yeah.
Awesome. Okay. Well then, everybody who's watching, thank you so much for joining. And
yes, thank you.
See you next time.
Bye-bye.
Bye.